Hello everybody. Today's topic, arc lengths in sector areas. Arc length and sector areas are actually not that bad to do. The formulas, you kind of have to think about them a little bit. You might have to memorize them. They should make sense as to what we're doing with them. So let's just dive in and see what I'm talking about. Okay, first of all, an arc length I have highlighted here in orange. We're trying to figure out the length of this arc. That's different from the measure, which would be a degree measure. We want length. Okay, so don't get those two confused. Okay, we're trying to figure out how long this line is. Now, think about it. This length is only a piece of an entire circle. And if we wanted to know the length of the entire circle, we would be using circumference, which is 2 pi r. So we're comparing the length of this piece to the entire circle. That's what this first piece tells us. Length compared to entire circle, circumference. But they also give us a little bit of information here too. They give us a measure of a central angle as x. Well, we're going to be taking that central measure and we're going to be comparing it to the entire circle, which is 360 degrees. Okay, so the arc length formula, we take the length of the piece we're finding compared to the whole circumference. We set it equal to the angle that's created at the center compared to the entire circle, which is 360. So what we've just figured out is two ratios that we can compare and figure out the value of L. Now, the instructions tell you to leave your answers, your instructions tell you to round your answers to the nearest hundredth. So let's just make sure that when we do that, we round to the proper place. Okay, so here's the kinds of problems that we're going to be faced with here. Okay, find the arc length to the nearest hundredth. Well, I'm going to quickly just label a couple of things. I'm trying to find L. This central angle, that's my x value. And the radius they gave me here is 7. Now, when I plug into my formula, length over 2 pi r equals x over 360, I just have to plug in values. Okay, length, that's what I'm trying to find. That's not going to change. 2 times pi times radius of 7. So 2 times 7 is going to give me 14 times pi. Now, let's take a quick pause. Right, I'm leaving this as 14 pi. Why am I leaving it as 14 pi? Because when I use my calculator, either at school or I can even use the calculator on Google, it's going to be a lot easier for me to just do 14 in the pi symbol, and it's also going to be way more accurate. Okay, so let's just leave that pi how it is. Anyways, continuing on. We just said that our x value, which is going to go up here in our formula, is 93. So 93 over 360. Now we're trying to solve for length. Length right now is being divided by 14 pi. So to undo that division, we're going to have to multiply by 14 pi. That will cancel it out from underneath length. But what we do to one side, we must do to the other. So we're going to have to multiply 93 divided by 360 times 14 pi. If you do this on a Google calculator, you can use parentheses and everything else included. So let me clear all this stuff out. Alright, so we want to do 93 divided by 360 times 14 pi. And that gives us 11.362. That too tells the 6 here to stay as a 6. So the length of the sector that we're working on is 11.36. We were working in centimeters, so we'll just put that label on. Okay, and it's just that easy. You plug into the formula to what you're supposed to have for those values. You multiply to get rid of the thing dividing length, and you're all set. So let's check out another problem. Okay, again, length divided by 2 pi r is equal to angle over 360. Here's my angle, here's my radius, that's the length I'm trying to find. 2 times a radius of 5 is going to give me 10 pi. The angle that they gave us is 121 divided by 360. We need to multiply by 10 pi on both sides. So again, what we're going to be typing in, 21 divided by 360 times 10 pi. So let's go back to our calculators, clear them out. Okay, I've got 121 divided by 360 times 10 pi. And they tell us that that answer is 10.559. Length equals 10.559. Okay, we need a round. 9 tells that 5 to jump up to a 6. So we've got 10.56. Here they're talking inches. So let's put our label. The length of that arc would be 10.56 inches. Okay, a couple more problems to try out. If you'd like to try these on your own, go for it. Pause the video and resume when you're ready to check your answers. Alright, length over 2 pi r equals x over 360. Well, here the length they gave us is 3. So 2 times 3 is 6 over pi. I'm sorry, not over, times pi. So 6 pi. The degree measure that they gave us here is this entire length of 264 degrees. We want to use that entire piece. So 264 over 360. We want to multiply by 6 pi to get it out from the bottom. So length is going to be equal to 264 divided by 360, and then we have to multiply by 6 pi. So 264 divided by 360 times 6 pi. Make sure I have that all typed in right before I press enter, and it says 13.823. This 3 tells my 2 to stay the same, so my length here is 13.82. We're talking meters, so we'll put my label on, and that's my solution. Alright, we've got one more problem to do. Length over 2 pi r equals x over 360. Here they give me 42 for my x. Radius they give me as 6.5. So 2 times 6.5 is 13 pi. And again, all we need to do is multiply by 13 pi on both sides. That clears it out here. And I'm going to be doing 42 divided by 360 times 13 pi. And the calculator tells us that that result is 4.764. The 4 tells the 6 to stay the same. So 4.76, and we're talking feet, so I'll put my label. That's it as far as arc length goes. But if you remember, the title of this section is arc length and sector areas, so we got to still check out sectors. If you don't know what a sector is, I would suggest going on to the website and checking out the vocabulary. It will define a sector for you. I will give you a brief explanation. A sector is a piece of an area of a circle, just a piece of the area. Okay, so you'll notice here our sector is highlighted in orange. Okay, and I also labeled it as A for area. Now remember, we're talking about a piece of area, so we're going to compare the piece to the entire area of a circle, which is pi r squared. Notice they also give us r. And again, we're going to be comparing that to the angle measure over an entire circle of 360. So they gave us a piece of the angle that's created from the sector compared to the entire. So this is the formula we want. It looks very similar to before. Before we had length compared to circumference equals angle over 360. Now we have area over area of a circle equals x over 360. So it's basically the same thing. It's going to work the same way as well. Okay, we're just going to plug in, perform what they ask us to do, and then solve. So if you want to try any of these out on your own, I'm sure that you can figure it out before even this first example. They're pretty basic. Okay, we're trying to find the shaded area here. That's the striped part. You notice we got an 83 degree and 3-inch radius. So area over pi r squared equals x over 360. Radius here is 3, so if I square 3, that's going to give me 9. So I'm trying to find area over 9 pi. The angle they gave us was 83 degrees over 360. And again, like I mentioned, it's pretty much the same process. We got to multiply by 9 pi on both sides to get rid of it from underneath area. And then what we're going to be typing in is 83 divided by 360 times 9 pi. We hit enter. Calculator says 6.518. We look at the 8. It tells the 1 to jump up to a 2. So area equals 6.52. Here we're talking about inches. This is space, so we're talking about squared, or I'm sorry, talking about area, which is units squared. So make sure that we put inches squared as part of our solution. Okay. Next problem. Find the area of the sector to the nearest hundredth. Yet again. So they gave us a radius of 4. If we use the same formula, pi r squared, so 4 squared is 16 times pi. The angle in question here is 124 degrees over 360. We're going to want to multiply by 16 pi. So remember what we're multiplying here. 124 divided by 360 times 16 pi. Let's go back to our calculators real quick. 124 divided by 360 times 16 pi. We press enter. The calculator tells us 17.313. That 3 tells the 1 it needs to stay how it is. So our answer is 17.31 millimeters squared. Okay, 2 more problems to try out. Again, you can try them on your own, or you can try them with me at the same time. This one's a little bit tricky. Notice that the shaded area out here is given, but the angle that they give us is not shaded. Well, that's fine because I can figure out the shaded angle by subtracting what was given from 360. So 360 minus 50 is 310. The angle that I really care about here is not the 50, but it's 310 degrees. So that's the value that's going to go into my formula. So A over pi r squared. Radius here is 3, so 3 squared is 9 pi. We just found our angle to be 310 degrees over 360. What I want to multiply by here is by 9 pi to clear it out. So we have to type in 310 divided by 360 times, here again we have 9 pi, so we type all that in. Computer tells us that area equals 24.347. The 7 is what's going to tell the 4 to move up. So 24.35. Here they give us meters, so we want meters squared. Okay, one final problem to do. Let's check it out. Notice again the shaded sector that we're trying to find right here. They don't give us the angle measure. They give us the opposite. We don't want that. So 360 subtract 208, 152. So the angle right here that we care about is 152 degrees. I'm going to cross that one out of there. The radius they gave us was 5. So if we do area over 5 squared, which is 25, times pi, that's going to be equal to the angle we found of 152 divided by 360. We're going to want to multiply by 25 pi on both sides. And easy enough to do. One last time, we go back to our calculators and we do 152 divided by 360 times 25 pi. And the calculator says 33.161. That 1 tells the 6 to stay the same, so 33.16. We're talking feet squared this time. That's our final answer. So we've gone over arc lengths and we've gone over sector areas. They're both pretty much the same process, slightly different formulas. If you can remember that sector area matches with area of a circle, that formula is easy to remember. Arc length matches with length of an entire circle, which is circumference. Then these problems become pretty easy to do. It's just a matter of plugging in and typing into a calculator and rounding properly. Okay, any questions you have, please leave them on the website or bring them with you to class, and we'll check them out as soon as we can. All right, have a great day.